Welcome to the Arcfluence podcast, where we chat about how design impacts the way we live, work, and invest. I'm Nick Caracan, your host. I'm here with my co-hosts, Paul Fatkins and Nino Samarzik. Welcome, guys, to episode 6. Paul, today we're talking about a topic you're very excited about.
It's my favorite topic of all time.
Yes. Why don't you tell us a little about it?
Basically, how to work smarter, right? Not harder. So essentially, if you think about scanning, that's basically what we're trying to do, right? We're trying to get rid of the human factor of it, where we have error and, not representation of what the space is, and basically get rid of all that and just work in a more efficient way.
Okay, so let's take a step back. What exactly does a scanning do in architecture, and what is it? What does it do for us?
There's two ways to think about it, right? Scanning is also called like reality capture. And it's called reality capture because it's basically a digital twin that you're making, right? So everything you see around you as we sit here in this space would be captured by the scanner. Not only the, distances between walls, the distance between the floor and the ceiling, but like even all the furniture and equipment that's in the room. I mean, literally everything, windows, shades.
Which is why we step out of the way when the scanner's working.
Ideally, yeah, because it's line of sight. But I mean, essentially, it's capturing the reality around you, right? And then you get all that and you plug it into your computer. So,
well, let's go back to before we actually had a scanner and what the process was for taking measurements at a property. The whole goal of this, right, is to get an idea of what the space is, so that we can then transcribe it onto AutoCAD or Revit to make our 3D model and produce a set of construction documents.
Yeah, this is definitely the funner part of the story, because the scanning stuff, it's it's exciting, but at the same time it's like you go do your thing, you plug it into the computer, off you go, right? When you go out to the site and you have to sketch it,
well, first of all, it takes 2 of us, at least.
Yeah, but it's like, I remember in the early days you had a notebook, right?
Yes, I would have to sketch out, if let's just say we have a house, and I would take a notebook, I would sketch out the space of what we're working in, and then Paul would have the one end of the tape measure, I'd have the other end. He'd call out what it was. I'd write it down. I'd write the wall on the thing, or vice versa. I forget. It really depended on each project and our mood that day. But we'd go around to every single wall, and we'd
how much coffee we had that day.
Correct.
Yeah.
So I mean, and we'd get it down to what, 1/4 inch, 1/8 of an inch. At least we'd try.
Usually should be 1/4 inch in architecture. Yep. Yeah.
And we every time we'd get our measurements, and we'd spend hours on a site. I'd go home, and then I'd sit down with my sketchbook. I'd get a glass of wine, and I'd get into CAD, and I draw a room, and the room corners don't connect.
Or this is the best part. You would take a picture on your cell phone, and this is like 5 generations ago of cell phones here. So you take a picture and you text it to like me or Nino. Okay, here's my sketch and here's the measurements. Yeah.
Hey Nick, by the way, did you actually double check the thickness of walls?
Hey, is there a window over here? It looks like in the picture there's a window, but in your sketch here, I don't see any window. I guess I'll go back tomorrow.
He forgot about that wine part.
And that's another thing. We would take pictures of spaces, but we wouldn't necessarily have video.
Yeah.
So and we'd have all these inconsistencies, and I'd have to go back to the property. It was just so much more time, so much more energy, and
just wasted time,
and less accuracy.
Less accuracy. That's the most important thing. Yeah.
So then we get a laser measurer where it's just.
Yeah. So I think the 5th iteration of you sending like the picture with the text phone, I'm throwing my hands up at that point, and it's just like, come on, like we can do better than this. So I think at that point I started to research, what are ways that we can, and I think at one point I even had like an adapter for the iPad. I think if I remember right.
How many years ago? Because Matterport was the first
Matterport. Then like I started, going down that trail as well. So Matterport, it was like a more broadly used reality capture tool, but it was more like real estate people, because it was based on photos and infrared light. So I was kind of researching and doing different stuff.
That was about 8 or 9 years ago, 10 years ago?
almost something
Yeah.
like that.
Wasn't some kind of issue with the scaling in the metaphor or something?
Scaling, yeah, was an issue. The accuracy level was an issue. If you go outside, like the earlier generation, and there's bright daylight, like it wouldn't capture
it's
things.
an infrared scanner as opposed to a laser scanner.
Yeah.
Right.
So
like,
that's a big difference.
yeah, like the sun would mess with it, like the brightness and the ultraviolet rays, and it would just jack it up basically.
And if I recall correctly, it has been a while, but we've had to. The distance between each scanning point was a lot shorter, so we'd have many more scans.
Yeah, or again, like with that Matterport and the older technology, if you went outside with it, it would just fail.
Not
like
work
you
at
couldn't
all.
even
It's too bright.
move it an inch. Yeah, it just wouldn't work.
Great. So we did a lot of guessing back then.
Relying on pictures, I will say, and your notes.
Yeah, and the notes. Yeah.
Great.
But yeah, so that started us down that path, right? And so it's like it's not like we just went out and said, "Oh, we're just going to buy a scanner." I think we got to the point where the sketching we realized had issues and we wanted to resolve those issues. And so we started to research and kind of methodically go through, well, what about this? What about that? I think even at one point, the iPhone system had the LiDAR scanner on it.
Yes.
Right.
And didn't you put that on the iPad?
Yeah. And so like I was trying to use
Oh,
an
I
app.
remember that. Yeah.
Yeah.
But,
I mean,
but
like,
it wasn't as accurate as we needed it to be.
No, God, no, not at all.
And
like
at the end of the day, it still wasn't saving us a whole lot of time, which
No.
is
no.
That's what you need professional equipment.
Yeah, yeah. So at the end of the day, like after all the playing around and all the research, to what Nino said, you just need, if you want the results, you need to pony up and pay for it.
And
you
Paul-
need that professional level of equipment.
Paul calls me and he's like, we need to buy a $20,000 scanner.
Yeah, I can't remember what you said after that.
I said,
There might have been
to
some
eat.
expletives. Yeah.
I like to eat.
So 20? Did you say 20,000?
Yep. And then I quickly did some research and we ended up financing it because we didn't have $20,000 at the time.
Yeah.
That's what you have financing.
Yep.
Yep.
So we ended up paying $26,000 for the scanner. But let's talk about that. How long have we been using? Paul, tell us about the Leica.
I think at this point we've had it now for what, 2-3 years, right?
I think
I think longer.
a little over 3 years now.
Yeah.
Yeah. I mean, essentially, it's game changer.
So what's the model number? Walk us through what that looks like. What are some of the specs? What are some of the advantages?
Yeah. So it's a Leica BLK 360. Leica is a company that is in the industry, architecture, construction industry. They have a ton of like survey equipment, even just like your handheld laser measurers, and Leica I think also does like lens manufacturing, and basically they're like top notch, top quality,
Top
in the
of the game.
profession. Yeah, the scanner that we have, it can see all around you 360 degrees. And it can see above and below. It just can't see directly below you. So it's not 360. It's like 360, 300 degrees of vision. And then as far as the range, you can go up to 60 meters and retain your accuracy.
And you can also take photos and other.
And the accuracy, it's all metric for whatever reason they decide to put all their measurements in metric. But accuracy is up to six millimeters at a 10 meter distance. And so in general, the ranging accuracy is like 4 millimeters to 7 millimeters. But basically it's around 1/8 of an inch is what you can think of it, for the accuracy. So it's a little bit better than like an industry standard.
Which is quarter, yeah.
Yeah.
So there's several advantages with this technology. Obviously, it doesn't require 2 people anymore. You can actually go and scan jobs by yourself. I can go scan jobs by myself, although it doesn't always work out exactly the way I planned. Paul, you do a lot more scanning than I do.
But to be fair, so again, compare the first going out and sketching, right? And then we get into like the Matterport. Like, what was the comparison there? Like, would you say 10 times easier?
Oh, yeah.
Yeah.
I would say the Matterport was a little bit more difficult to use because the connection between each point never was always troublesome, and we had to do so many more scans. We're doing a lot less scans now. The connection's a lot better. I think the technology's better. It's faster. It's a faster scan.
Yeah. Well, yeah, and then like you said, like you're going point to point because obviously you can't just jump from like one side of the building to the other. It has to know what it's connecting to as you're going and stitching all of these things together.
Yep.
But I mean, like, again, ease of use, right? 10 times easier.
Well, how about on the drawing side, Nino? You've had point data from both machines. Did you notice a difference? Obviously, there's more data points with the Leica.
Yeah, the scanner is more precise. You can even see like some deformation in construction. It can tells you that maybe there is some issues with the structural components of the building. You see some sagging and stuff like that. It's very accurate.
So when the client says, "Why is my wall crooked on the construction documents?" It's because the wall's crooked.
Balls are crooked. And one things I would like to mention, and architecture, and for many people that maybe don't know that, is not just nice new buildings. Majority, I will say 80% of the real architecture is renovations and additions. So capturing the existing condition of the space is crucial.
Very important.
Very important, and having accurate data that are captured precisely and fast and effectively is very important, because I'm working in a company that are still relying on people to make the measurements, which is so prone to multiple mistakes.
Well, sure, a lot of big firms, they send their interns out, to cut costs because it's such a time-consuming event.
And again, talking back to the beginning, right? Measuring by hand. You go out, you go into a room, maybe you take a measurement across, so that's one data point. You take another measurement across, that's another data point, right? Like, that wall could be crooked. If you take a measurement on one side of the wall, it could be a couple inch difference compared to the other end of the wall, especially if it's a long 150-foot wall, right? So if you're taking one data point and you're just measuring across, okay, that's my measurement, I'm just gonna, and you just draw everything like
you'll
straight.
mirror it to save time, and it's not always correct.
You just make assumptions, basically, and you only have like a couple data points.
Right. Now, what is most importantly is, I'm sorry, I'm cutting you off. No, it's actually be capturing 3D space, because when humans go, and especially young interns that thinks nothing about how they're gonna, about 5 o'clock when they're gonna go home, when they're capturing the space, and I notice that when I'm actually measuring the space, like manually, you mostly concentrate on a floor plan, on a floor plate, which is two-dimensional things. And God knows how many times I returned back to office and I was like, did everyone put information where the windowsill is?
Yeah.
And everybody looked at me like a pale. I was like, no. Can we look at the pictures and try to estimate it?
Yeah, you're counting bricks
good luck
at that
with
point.
that.
No, you have to go back.
You have to go back, and drives client like, especially if you have like I'm working a lot of in healthcare, and we actually measure one of these operational rooms, which actually brings a lot of money to the client. In order to schedule the measuring of that space,
you have to block it off.
You have to block it off.
Which costs the money.
They cost the money, cost the time, cost the organizational. You have to have people to escort you there. You have to dress up in a bunny suits and all this fun stuff. So if you miss like information, the client is going to look at you pale. It was like, are you supposed to doing your job? So that's what I'm like. What I like about these scanners, and I highly recommend.
Yeah. Well, but again, like for me, it's like data points, right? So if you go out there by hand, you can only capture so much. Like even if you measure, again, talking about a wall, you go on one end of the wall to the other side, you go in the middle of the wall to the other side, you go on the opposite end to the other side, right? It's still only 3 points of data, 3 measurements across. So then it's like a little more helpful. Mm-hmm. But again, if you have some intern out there that's just doing things quickly and trying to get through all these different spaces, they're probably taking one measurement and that's it, right? When we got to the Matterport, there was maybe like 100,000, 50,000 points of measurement when it did like a 3D scan of the space.
But now there's millions.
It's like billions in total. But it's like the scanner we have, the reason why it costs $26,000 is because every second it captures 360,000 data point measurements.
That is insane.
360,000 a second.
Now,
so
to be fair,
it's able to literally capture the reality.
To be fair, you still have to know what you're doing because you have to you have to draw the model and connect to the right points to make sure your drawings are accurate.
There's post-processing too, right? So it's like, obviously we have a tool to scan. Once that's done, we're taking it into another software to basically like homogenize it, whatever,
Yeah.
combine it into a unified,
Tied up everything. Yeah.
So it's a unified model where it's like everything's connected properly, and then that gets exported and put into our final software, which is where we actually like use it as an overlay, underlay, and can draw and reference and go into all different views.
Yeah.
Cut
So
and
the reality is, we may cut our site visits down for measurements for scanning, maybe down to an hour, a couple hours. However, there's still a lot of work on the back end, and I guess it depends on the scope of the project. For our larger commercial projects
and size,
we're there for a couple days, which is a service that ArcFluence offers. We can travel anywhere in the United States, but we use it for everything, like our houses, because when we process a house, we're then able to export it and send it to our team, and whether they work remotely or not, so we can do our work anywhere.
Yeah.
Yeah. I mean, again, just to Nino's point that he was bringing up, the value of it, right? It's really hard to measure it, because what you get out of it is just, it's incredible in terms of value. I mean, there's no guesswork, there's no assumptions, and everything is exactly as it is when the scanner sees it and measures it.
And also, we get inquiries where they have gone out and measured it by hand, and there's inconsistencies after they've started the project.
Yeah.
So they'll call us in, we'll go in and scan to verify everything, and then they can do an overlay with the scan data onto the existing model that they created and find out what exactly is going on.
And good thing is actually can be used by like a multiple team members. It cannot be only architecture, can be used by structural, as I already mentioned, MEPs, because you also can capture all these existing ducts if they're like exposed. Just keep in mind these scanners cannot see through the walls. But stuff like that can be easily shared with the multiple team members across the board, which is a good thing.
Yeah, and I'm glad you actually brought that up. So yeah, it's not an X-ray machine, right?
Yeah, just so people let you know that
yeah. So if you have a ton of crap, right, in an old house that some hoarder was living there, basically you'd have to go in and have it somewhat cleaned out, right?
Yeah.
So that the scanner can see everything that it needs to see.
Can you more talk about preparation for work? How are you actually mapping out the tour that you're gonna go like through the building?
Sometimes, but not. I mean, it's kind of difficult. Sometimes you show up, you don't really have anything pre-existing, right? If it's a commercial project, you might actually have like a pre-existing drawings, right? Yeah. And then where you need to like do some scanning work, and you kind of have something where it's like an existing space and you have something to start with, right? Now, obviously, if someone gives me a plan, I don't just like assume it's accurate. That's why we go to scan.
Exactly.
Right? We go to scan to verify that whatever we're given as a base drawing is accurate, and we can go off to the race with the design work, right? And know that all of our measurements are correct. But if it's a house, you kind of get there and you just assess on site, right? But I mean, it definitely should be is cleaned out as much as possible. Like even for me, even if there's like shades and drapes in front of the window, a lot of times we'll just do an interior renovation, but I'll say to Nick, well, I'm going to scan the entire outside.
Yes.
And at first he was like, okay,
why are we doing all this extra work, Paul?
Yeah. He's like, we're just doing some work on the inside. He's like, we're not touching anything on the outside.
Because we don't see where our windows are.
Yeah. And I'm like, Nick, have you gone in the house? Like there's a ton of crap everywhere. There's stuff blocking the windows. Like,
now we have the proper window openings, dimensions, so we can do a window and door schedule.
Yeah. So the scanner would see the blinds or see the drapes, and it's gonna literally scan that, and it doesn't see what's behind the blinds or the drapes, right?
And it's not bothered by light. You're mentioning.
Yeah.
So you can actually scan in like a direct like a dark space.
Darkness.
Yep. It could be completely pitch black, and it would be able to
see. Which some properties they don't have having power because they're just being abandoned.
Sometimes that's the case.
Yeah.
The biggest issue, so it's not light. It doesn't need to be like lit up properly. The biggest issue is more just like the line of sight.
Yeah.
And being able to see things. So, like you said, it's not an X-ray machine. It can't see through something. So, yeah, we would just do the interior space in the scope of work, but I would scan everything on the outside so that all the openings are basically hit, and we can see all the openings for the windows.
And also when you're scanning like a smaller spaces, like a closets and stuff, there is a way how you open the door, how far you open the door, so you can actually see it inside.
So that's usually what Nick does. So I say, hey Hey, Nick, run around, open all the doors for me.
I'm Paul's helper. But we go to the sites. You do some scans by yourself, and you're able to do that by yourself. But a lot of times, our clients are meeting us for design consultations. So I'll show up. I'll talk to the client. We'll go over their vision. I'll give some feedback. We'll come up with some type of collaboration, have a discussion about it. Yeah. I'll open all the doors for you. Well, and I'll also do 3D video.
Yeah, as long as you're not occupied. Sometimes you and I will just go to the site and it's just you and me there, measuring stuff. Then Nick will kind of chip in and help because he doesn't have to sketch things anymore.
Yeah, and I will say 3D video is also helpful because get you grasp the context of the project that you're working on, and plus Nick will while walking around with the camera, he will actually specify some items that he laid out with the clients, what they actually would like to do with that space in the future.
And that's also why we have the ability to take photos through the scanner, but it does add time to each scan. So, at least in residential stuff, I'll take our 3D video and I'll be able to talk through all of our designs, my conversations with the client. Take note of the location of the electrical box, and certain elements that'll help kind of bring everything together.
And back to some of the prep work that you were talking about, Nuno. So the doors are propped open, so that way, again, it's like if I go into a room and the door's already propped, right, I can go into the room and then go over to where the door's already propped and go into, even if it's at a 45 degree, and then go into that closet or that laundry room or whatever's on the other side of the door in the space there. If it's closed, then I'm coming in, I'm doing scans, and then after I do scans, I then have to go over, open the door, do another scan, and then go into that. So it's like there's extra steps if we're not going around and prepping properly. Or if things are blocked, then obviously you're not getting the information. That's why, again, if things are, blocked on the inside, I'll go and scan the outside, because then at least there's not something in the way on the outside. I can still see it.
I see that. How are you actually scanning stairs, if they're especially long ones?
Same kind of process, all line of sight.
Our $500 tripod is able to adjust onto each step.
But I can't just go from... It's same thing on the outside, right? I can't go from the front to the back, right? So if I have a really extended staircase, I can't go top to bottom. Done.
Got it.
So I have
because
to
of the range. Yeah,
at least a scan in the middle. The range is not an issue. It'll see up there, right? But again, to guarantee the level of accuracy that we kind of demand, especially using this tool, you should
drop the middle point. Yeah.
Absolutely, yeah. So that way we can basically guarantee that accuracy and stitch as we go up.
Or if stairs turn 90 degrees, and it's all enclosed in a wall, then you have to go
I definitely points. I actually prefer the shorter stairs that have the turns in it, because then I can go landing to landing.
Exactly.
Yeah. If it's a really long one, then it becomes cumbersome, because then I got to make these adjustments to tripod and set up in the middle, and then go to the top and readjust the tripod. So a little bit of a delicate process, but I mean, it's not that bad once you get on site and do it.
So what I also saw the benefits, a huge benefits, when you're actually scanning outside, I will see fences and stuff and see the property lines, which is very helpful because many of these properties, especially in residentials, they don't have surveys done, and what is actually the distance of the building to the property, and
it'll see further. It'll see
trees and stuff.
It'll see over 100 meters away, 300 feet away into the distance. It'll trees. Everything, and it'll have the entire neighborhood. Maybe we can post a screen capture of one of the raw outputs of the neighborhood.
And quite often I will actually see you guys talking to the client on the scan as well. So that's so funny.
Well, Tonino, to your point, also if you see a fence line, without going to the auditor's site, you can kind of assume that that's the property line, and that we know we're going to have a fire-rated wall because we're less than 5 feet.
If you're too close, exactly. And also you can actually tell when your the sidewalk curbs drops, when the road starts. So because many of these, especially if you find this online websites from the cities, they're not super accurate. There are still good tools, but they're not super accurate, especially if you have really tight property. Yeah. Every inch matters.
Yeah, and then again, even if we're only doing an interior renovation, going back to prep and what we think about when we're there on site. So one of the things I'm thinking about too is thickness of the wall even. right?
It's
Because
very
I can't.
important. Yeah.
I can't see from inside to outside. So the only way to capture that thickness is to take a measurement that hits the outside surface, work my way inside, and take a measurement that hits the inside surface. And then that discrepancy is the thickness of the wall, and bam, I got it.
Because many of these buildings, especially old one, they evolve over time. They're being renovated and renovated. They have multiple layers of different stuff in these walls. So that is very crucial, very important to capture it. But one thing that I will mention it too is that doesn't give still leaves the obligation for a contractor when he start demoing work. If he actually discovers something that was being assumed on the drawings because we just simply cannot see through the walls, he still is obligated to report any unusual inconsistencies to the designer.
And we can always give a heads up though if we notice like an unusually thick wall.
Yeah, unusually thick wall, or if they're just in one of the properties, if they decide to remove entire roof, well, that's completely different atmosphere now. If you're extending the building or adding pitch roof to the roof that was previously flat, so it can cause multiple complications that every contractor needs to report to the designer.
Yeah.
Many cases, architect.
Yeah, and so, in a lot of times when I'm on site, like I'm trying to map through and think about all these different things. And then, again, like if it's a residential property, I'll show up and just kind of map it out as I go. If it's a commercial property, I might have a plan where I can kind of map out all the different areas that I need to capture. Another thing you mentioned for commercial spaces, you might have a drop ceiling where you actually have to like pop some ceiling tiles.
Yes.
And
if you have ceiling tiles, if it is not gypsum, that you cannot cut it out.
If it's, it is what it is. If it's gypsum, at that point, it's just scanning the ceiling. We're not going to like do demo work out there. But like I've actually had to get scissor lifts before for a commercial property, and go up, pop ceiling tiles on the scissor lift, and then put the scanner up inside of the ceiling to get all of the ceiling space.
Oh, that's nice.
Scanned.
So actually can capture all these duct work,
everything that's
pipes.
up there. Yeah. So then I'm going several locations all around with, it's fun to drive the scissor lift. You're like driving around and get the little joystick and then you go up. It's scary when you go up though, because it actually
is.
Have you ever been on one?
Oh yeah, it wobbles.
I was actually on once. It's a lot of like a
if you're outside,
rocking.
So inside is much better than outside. If you're outside on a windy day,
oh boy.
I
was actually
I've been
inside
always. I've not been outside.
I was actually outside. It was like a weather today. It was kind of cold and it was windy.
Well, now we have the drone, so instead of getting access to a roof if we need to like document some type of equipment, now we just fly the drone up there.
Yeah, take a few photos. But if we need to scan, we still have to go up there.
Right.
Can you say now more about, you mentioned God knows how many points, measures in a seconds or whatever, so that's a lot of data.
Yeah.
I'm guessing that's very big files. So how are you doing all this stitching together? How are you transporting these giant size files? How are you managing with all this?
So the scanner itself has an internal hard drive, right? And it could save a few hundred scans, which usually for a residential project, we can scan anywhere from like 30 up to like 70 for like a residential scan. So every once in a while, I do have to go in and like purge out all because every time you do a scan, it automatically saves it there. And then it also saves it on my iPad, which then I'll transfer later to like the computer.
Well, we've had some large residential projects and even commercial projects where there's 100 plus scans easily. And then you've had to delete past projects because we ran out of room.
Yep. So like there's a management on the size of it as well. And then when you get it into the software, so it's like all the raw data, you're talking like one project could be 10 to 20, 30, 40, 50, depends on the number of scans.
Yeah.
But it could be up to like a couple hundred gigabytes of space. I mean, large amounts of data. Because again, like the amount of data that it's collecting is enormous, right? Then when you actually go to output it, you stitch it all together, you make this unified model, and then you can kind of basically say, okay, we're going to stitch it together. And like, if you have duplicate points, kind of clean that up essentially and make a little bit smaller file. So then your final output might only be several gigabytes. The software does it.
Software does it. Wow.
So because to connect it, you need overlap.
Yes.
So you're going point to point to point. And it can see where it was before to where it is now, and then it can make the connection and basically align everything to give you the entire building all the interior spaces, doors, everything, right? But again, that overlap, it's duplicated data, right? So the software kind of knows that it's duplicated data. It's used primarily to make the connection. Once everything is connected and you go to actually output the final thing, then it gives you kind of a clean, unified point cloud. So then, like, even though you might have like 50 to like 100 gigabytes going in of raw stuff, you might have like 10% of that coming out as like your final model that you dump into Revit. So you're still going to have a several gigabyte large file that you have to dump in. And sometimes it can be tedious to work with, but you know, again, like, you can section it down to like certain view or crop down, and it makes it a lot easier to work with.
So is it like a third-party software, or that's a software?
It's all through the company that makes the scanner. So it's
makes
Leica.
the scanner.
Yeah,
that's good.
Yeah,
that's
so Cyclone is the platform, the software, and it's Cyclone 360, and it's for the Leica BLK 360. And yeah, it just dumps into their proprietary software. It's a proprietary file that they have.
That's good.
So yeah, they kind of handcuff you to basically using their process and their system.
All scanners and companies do that, essentially.
But at the same point, if something goes south, it's one point of like, you know, customer support. My apologies.
The cool thing about using the Leica scanner, though, is we keep and store the data ourselves.
Oh, yeah.
So it's not being stored on their drive. They're not controlling the information.
That's good. That's a good point that you mentioned.
And I'm glad you mentioned that, because back in the day when we did the Matterport, I think another reason why we got away from the Matterport,
because it's actually sitting on their cloud.
They control everything. And as soon as you stop paying them your monthly subscription, they say, "Great,
it's gone.
It's gone. Goodbye."
Wow. Wow.
So if a client says, "Hey, I want to," if a client comes back like 6 months or a year later,
that never happens.
It never happens at all. Never ever.
Happens.
Projects take a week and that's it, and then they're done. And
happens
move on.
always.
But we don't have to worry about that anymore. Thank goodness.
Yes. Well, and here's the other. So like another great benefit, right? 2 years down the road, you know, say something is needed, the client for whatever reason decides not to move forward at the time, then they finally move forward. Then 2 years later, for some reason, something doesn't quite match up and they want to look at something, they come back to us. I can pull up the file on my computer 2 years later, look at what we scanned 2 years ago. Okay, yeah, your floor joist should be a 2x8 here and a 2x10 here based on the difference between floor and ceiling, you know, between the two spaces. And yeah, so what's your question? Let's talk through it.
Yeah, we can have a thoughtful conversation without even doing a site visit potentially.
Because we have all that data that's stored and captured.
There.
Yeah.
Now, when you stitch everything together in that software that is proprietary for the 3D scanner company, so how then you transfer the data to BIM software?
So Autodesk has, Recap, which is basically their software that is for like point clouds. And the format is an RCP file. And that file type is basically like universal in all Autodesk products.
Got it.
So Revit automatically recognizes that file and we can just plug it directly in.
Just link it directly.
Even now, I think, so Autodesk, I think, acquired Twinmotion, which is like a rendering software.
Yes.
Yep.
Yeah, even you can take a point cloud data, put it into Twinmotion, and then you can have someone do like a walkthrough, fly-through of like the existing space. So say you have a client that's even remote. And okay, well, what'd you capture out there? I haven't even met the property. I'm just the investor. I'm buying it. I hired the contractor. I hired you guys to do the drawings.
You can have them walk the space.
I can literally walk the space with them on my computer.
Yeah, you have big clients that they just like purchase the property and they never been in it.
Yep. Well, we're licensed in Hawaii, so I am planning on getting a ticket ASAP.
So you're gonna be exclusive on the scanner measure.
Yes, I'm gonna be scanning
for Hawaii.
Just for Hawaii. Just for Hawaii.
Just for Hawaii.
Yeah.
Okay.
Oh, Minnesota in January. Oh yeah. I'm busy. Paul.
Yeah, I probably gonna be Paul.
Absolutely, we can do that. Paul is on his way.
You got a winter hat, right, and boots. Yeah. Off you go.
So let's talk about what's next. I know Paul has already, we haven't even finished paying off this scanner, and Paul is already telling me about a new scanner.
Wish list.
That's $60,000.
Yeah, roughly.
Yeah.
Roughly.
And three times the cost.
Yeah, and I smiled at him.
Yeah.
So walk me through that. Convince me. Sell me on this.
I think we'll get there eventually. It's just so. I mean, like, this is great, right? The new updated, whatever, better version of this does pretty much everything that this guy does, but on a
what
higher,
am I spending this money on, Paul?
but at a higher rate and at a better level. So like, again, like if you look at like the corner where two corners come together, right? It might be a little whatever fuzzy basically with the scanner that we have. Now, I'm trying to think of a way to explain it so that you can understand like what I'm talking about.
So instead of being it's not accurate to an eighth of an inch, it's accurate to
like a 16th
of
or
an
a
inch.
32nd.
Or 30
So it's a high accuracy.
So it's higher accuracy,
higher range.
it's higher range. So
Can
like
it cook me dinner?
no, I can't cook you dinner. I can't help you there.
60Ks, yeah.
Yeah. But say you're on a site that you have a 20-story building, right?
Exactly, yeah.
You can scan from the ground to the top and have the accuracy maintained at the top.
That's very or you have like a very big atrium that you have to scan. Yeah.
Now, something like our scanner can still probably capture some data points up there, but I would be slightly suspect if I'm measuring from the ground 20 floors up, right? With the accuracy of the data that is captured.
There is another option is actually tying Paul to the like a crane or something,
That
and
sounds
just
like
like
fun.
and let him just like
Spider
dangle,
Paul.
like dangle down with the scanner.
Well, no, not with the
Paul.
scanner. No, let's just dangle him. The scanner's too expensive.
Jeez.
I hadn't heard that.
No, I was looking at the specs for the fancy scanner and the fancy scanner.
Yeah.
And it looks like it also is a lot faster in its scans, so it can
Oh,
capture.
yeah.
It's like 5-6 times faster. So again, if you go out to a site, if it's a small site, we don't need it for a house.
Yeah.
Obviously, this is more than adequate for a house. But if it's a larger space, if it's a space with a couple story atrium, or again like a multi-floor building, your speed, instead of spending 12 hours on site, you're going to spend 3 hours on site.
Yeah.
2 hours on site. So I mean, like,
So with the bigger projects, 60K won't sound that horrible.
So when I'm in Hawaii and it only takes me a couple hours instead of all day, I'll have the whole rest of the day to go to the beach.
Exactly.
Exactly.
All right, Paul.
Yeah.
That's what you need.
That's how you sell it. That's how you cook them a dinner.
Yeah. Yeah, we don't want you to work 12 hours measuring with this guy. We want you to spend the 60K and spend 2 hours measuring and then go to the beach for the rest of the day. Yeah.
Thanks, Paul.
That's cool.
Yeah. But better in every way. I mean, it's like the next, think of every time they release an iPhone, it's like a step better, right? So there were several years between when they released like the base level stuff to the next level up.
And to be fair, as a business, we're looking at redundancies, right? So Paul and I, you remember the story? It was last year. Paul and I are scanning at a house, and it's a windy day. And Paul, I love physics, and I know that when you open a tripod as wide as possible, it's as stable as possible. When you close it up a little skinnier, less sturdy.
Have tendency to fall, yeah.
Paul's a genius, and I don't understand why he likes the tiny base.
You have to go through doors.
All right, but we were outside.
After going through a door.
All right, fair.
Yeah.
So it's a windy day.
And just in my defense too. So we go through, I put the thing down, right? And this is in the middle of Nick, I don't know, having some discussion about some project.
It's my fault. I distracted
Hey, can we
him.
look this up? I need to look this up. I need to get back to the client, blah, 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 blah. Sure, let me start this scan and let's look it up. I think I was on my phone looking something up on site with Nick.
And we saw it start tipping in the
Mid-conversation.
corner
Wow.
in the corner of our eye,
Yeah.
and literally my heart stopped, and I'm like,
Trying to reach.
yeah.
Well, for whatever reason, and again, I don't know why you and I both walked away from it.
Yeah.
Like several feet away from it.
Yeah.
We were nowhere near it.
It landed very gently, like on a it didn't even fall all the way, and it landed in some soft mud.
Oh, good.
And we had to.
We had to like adjust fiddle with the adapter, but other than that, like everything
was good.
Couldn't believe it, but we do have insurance on it.
Okay.
But still, if the scanner goes out of commission, then how are we scanning our projects, right?
Yeah, good luck.
We'd had to bring out the Matterport again, which would have been terrible.
Yeah. But to be fair, the Matterport has also iterated, right?
Yeah.
So there's a new
they
version
advanced
of the
too.
Matterport.
Yeah.
Fair.
Right.
They
And they
advanced
connect,
too.
but obviously it's like we don't
So
have
do you
that
have
new
to do
version.
any like initial calibration or something like that with that scanner, or
So every so often you do have to calibrate it.
Okay.
Right? So there is a calibration process, but it's not something you do yourself. That's something that you would
it's
send
softer?
back to the
Oh,
company.
I see what
Yeah.
you're saying.
They would clean it out and calibrate it and do whatever, right? But it's not the thing is sealed up. It's, unless you're getting an error in your data or it'll tell you if there's some issue, right? Then you don't really need to send it off. So it's like every few years you do have to do some maintenance on it, but it's very minimal.
It's a minimal.
Yeah. So it's basically a highly accurate instrument, and you can rely on it, pretty much every day, year round, unless it like starts to complain. So it's very rare that happens.
What I also saw, what I actually have experienced people doing when you're mentioning drones and stuff is like these thermal imaging cameras, when they actually capturing the thermal performance of the buildings or a leakage. And especially in today's world of the sustainability, guys, that rain is the number one enemy, like entering the building, but the second enemy is the air that actually cause the building to not perform as tight as they need to be. And these new tools, especially using on flying drones, it can be very helpful to see where you're actually losing your energy and how your envelope performs.
Absolutely.
That's probably one of the, when we get a little bit higher in a more higher end commercial jobs, that's one really neat tool that you can use.
There's other scanning like softwares. It's I don't know if you can call it scanning softwares, but it's like photo processing from like aerial images. So you can take your drone out, you can actually program it to fly a certain path and take certain photos at certain angles. You can take all those photos in, and the terminology of what it is, it's like it basically takes the photos and it builds a 3D model. I can't think of it's for some reason it's eluding.
Yeah, I know what you're talking about.
You know what I'm talking about? There's a
Let's
term
create
for
a
it.
3D model from
Yeah. It's generated
from the video. Yeah,
yeah, it's generated from all the images.
Yeah,
and
from the images. Yeah,
it can be a highly accurate, highly detailed 3D model.
Yeah.
Captured from all these drone images that it basically processes.
Well, they have the scanner attachment that you can put on a drone too, so it'll fly around and scan those buildings as well.
Yeah, but I mean,
vibrations.
It's not exactly. They also have like handheld ones where you can walk through a space, but again, like there's issues with like accuracy and other stuff.
And some
like
of this
that.
equipment is also extremely expensive.
Yeah, that's true.
So I guess let's kind of wrap this up here. From an architecture firm standpoint, it really does benefit us on the side of accuracy and timing, and also just communication with the team. On the client side, go ahead. Did you want to say something?
No, that's what I want to say. It benefits clients as well. Yeah, because less surprises, the better. Because surprises in construction are usually a cost item.
Absolutely, after the fact. And I also think like those are questions you can ask your design professional if you're the end user. There's also a market for a lot of architecture firms themselves outsource this service, which we do for architecture firms. So like we're able to travel and perform this service for architecture firms, not necessarily someone who's looking just to do a design. So we can be B2B or B2C.
Yep.
Yeah. And by the way, photogrammetry, that's what it is.
That's how it is called.
So it basically it's making the 3D model from the photos. And just so you know, we also have the ability with all the point cloud data, we can take that and generate a 3D model like with a surface, somewhat like automated practice, and then you could send it to a 3D printer and print it out or put it in your models or do whatever with it.
You can make a little house on your 3D printer.
Yeah.
So,
I was curious, what does one of those machines cost? Did it give you a price?
For what?
The photo.
Oh,
it's
geometry,
software.
whatever it is.
It's software. So, it's any drone. You just have your pictures. You could even do it like if you have a statue on the ground. As long as you take enough photos from all angles.
Yeah, I saw that.
All around.
Actually can just like a hover over with your like a phone.
Yeah.
Around the object and can actually create
I've had
3D
to do
model.
like renderings before where there was like a park with like a sculpture, and the client wanted to see an image from the park of his building, and they wanted this stupid sculpture, and it was like some modern art. It is ugly in my opinion, but not.
It's a modern. Come on,
but not easy to model. I
Yeah.
couldn't just model it.
Oh yeah.
And like we didn't have like a laser scanner or something where I could scan it and like kind of put it in there and fake it. And then like I couldn't get he was so specific about this angle that he wanted, so it's like great. And I couldn't really like match it to a photo because there was stuff that was in the way. Oh yeah. So I had to go out and take a ton of photos and basically plug it into the software. I made a 3D model. And then awesome. In the software, I like deleted the trees so that I could get the view that he wanted. It's like, okay, here you go, buddy.
There you go.
But yeah, powerful stuff. It's just software that you can plug it into. Yeah.
Great. Well, hey, this was fun.
That was fun.
I think this is good information. I guess we'll keep you posted on if we get that new scanner or not. Yeah, that $60,000 one.
Yeah.
All right.
That cooks dinner.
That cooks dinner for me.
Yeah.
All right. Well, we'll stop there, guys. Thanks for joining us, and that's a wrap.
This has been the ArcFluence Podcast. As always, you can get more information and additional content on arcfluence.com. Please subscribe on the platform of your choice and leave us a review. We'd love to hear from you.